In this video, we'll look at Chapter 5, Section 1. We're going to solve systems of linear equations, first by graphing, in the next section by the method of substitution, and in the following section by the method of elimination. A system of linear equations is just one or more linear equations, and the solution is the ordered pair that uniquely satisfies or solves is a solution to each of the equations in the system. Now this first particular one I'm not going to look at because I didn't give you a large enough graph so that we could see the points of intersection, which is the point that lies on both lines at the same time. So I'm going to go on to number 19 instead. And in order to graph these, I'm going to have to put them into slope-intercept form, or that's one way that I could do that. X minus 4y is equal to negative 4. Um, Again, another way that I could do this, let's try it this way using the method of intercepts. Set x equal to 0 and I get negative 4y is equal to negative 4, or y is equal to 1. When x is 0, y is 1. Then we'll go on to set y equal to 0. When y is 0, we have the equation x is equal to negative 4. So when y is 1, x is equal to negative 4. And from this we can see we have a slope of up 1, right 4, up 1, right 4. We have a slope of positive 1/4. Y is equal to 1/4 x plus 1. So that would be the equation in slope-intercept form. Doesn't really matter that we have that, but we're looking for the place where the two graphs are going to intersect. In the second equation, we have set x equal to 0. When we do, we get negative 4y is equal to 12, or y is equal to negative 3. So when x is 0, y is negative 3. When y is equal to 0, we get negative 3x is equal to 12, or we have x is equal to negative 4. And so that is going to be our point of intersection there. We have a slope of down 1, 2, 3 over 1, 2, 3, 4. So we would have y equals negative 3/4 x with a y-intercept of negative 3. And so that would be our second equation if we solved for y. Either way is okay. You can graph it either way. Down 1, 2, 3, over 1, 2, 3, 4. And I don't think we have room for any more points on that graph. So the solution to this system of equations is x is equal to negative 4, y is equal to 0. All right, we'll go on from there. Now I am actually going to go back and take a look at number 15, and we're going to look at that using the method of substitution instead, since by the time you're watching this video you've already learned the second section there. And so we have y equals in both cases. All we have to do is set the two equations equal to each other. Since they're both equal to y, we get 1/3 x plus 2 is equal to 2/3 x plus 5. Remember, one way to get rid of fractions is to multiply both sides by the common denominator, in this case 3. So we're going to get 3 times 1/3 is 1x plus 6. 3 times 2/3 is 2/3 x is 2x plus 15. If I subtract 2x on both sides, I will get negative x plus 6 is equal to 15. Subtracting 6, I get negative x is equal to 9, or x is equal to negative 9. Remember what we do then. We take that negative 9 and plug it into either equation. Let's use the first. We get y is equal to 1/3 times negative 9 plus 2. 1/3 times negative 9 is going to give me a negative 3 plus 2, which is a negative 1. That gives me the point x is 9, y is negative 1, and you can see why that wouldn't fit onto our graph. Then we check by plugging both of those into the second equation. Y, well, if y is equal to negative 1, does that equal 2/3 times negative 9 plus 5? And so let's see, 2/3 times negative 9 is negative 6 plus 5, which does equal negative 1, and so that checks. All right, so our solution in this first example would have been x is negative 9, y is negative 1. All right, we'll go on from there. In example 27, you have 40 minutes to exercise at the gym, and you want to burn 300 calories total using both machines. How much time should you spend on each machine? Right, so we have seen word problems of this nature, and I don't know that we're going to be able to solve this graphically, so it is good that we have already talked about the method of substitution. So what happens? What are we trying to find out? How much time you spend on each machine. So let's say x is time on elliptical. Y will be time on bike. All right. So we burn 8 calories a minute. So on the elliptical. So 8 times the number of minutes we spend there, plus 6 times the number of minutes we spend on the bike, we want to burn a total of 300 calories. So that's one of our equations. Then the next thing we know is we have a total of 40 minutes. So we have x plus y is equal to 40. Now we know how to do this. We're going to solve one of the equations. This is an equation that's more easily solved using substitution because we have an x and a y by itself. It's going to make it a little bit easier. We could also solve this by elimination just as well. So if I solve for y by subtracting x on both sides, I would get the equation y is equal to negative x plus 40. I plug that into my first equation, 6 times negative x plus 40, that has to equal 300. And I get 8x minus 6x plus 240 is equal to 300. Subtracting 240 on both sides, I get, 8x minus 6x, I could have and should have combined those like terms first. So that's a mistake that is often made. I actually didn't have a problem with it, but some students make a mistake following that I won't get into here. But we have 2x is equal to 60, divide by 2, so x is equal to 30 minutes. If x is equal to 30 minutes, and I have a total of 40 minutes, then y will have to equal 10 minutes, and I'll plug them back into the first equation, 8 times 30 plus 6 times 10. Does that equal 300? 8 times 30 is 240 plus 60, and that does indeed equal 300. I have 40 minutes, 300 calories, and I'm good to go there. Okay, we'll do one more word problem. I don't think, again, that this can be solved using graphs that easily, but it's not going to matter. We have, by this time, learned all 3 strategies for solving systems of equations: graphing, substitution, and elimination. So let's see what we have here. You sell small and large candles at a craft fair. You collect $144 for selling a total of 28 candles. How many of each type of candle did you sell? So let's call X is the number of $6 candles, and Y is the number of $4 candles. X, number of $6 candles. Y is number of $4 candles. All right, great. So we know that we collected a total of $144. So 6 times X plus 4 times Y is 144. And we know that we sold a total of 28 candles. So that would be X plus Y is 28. Now this time I'm going to solve this one using the process of elimination instead of the other. And I can see that all I really need to do is multiply either the bottom equation by -6 to get rid of the x's or -4 to get rid of the y's. I'm going to choose the smaller numbers and I'm going to rewrite the equations now. 6x plus 4y is equal to 144. -4x minus 4y is equal to 4 times 28, which is negative 4 times 28, which is negative 132. When I do this, I end up with 2x is equal to 12. So that x would have to be 6, and since x plus y is 28, 6 plus y is 28, so 6 plus 22 is 28. And let's just double check. I did that all in my head without a calculator, so it's good to make sure that we have it right. Since we use the second equation to find y, we'll use the first equation to double check our answer. 6 times 6 plus 4 times 22, does that equal 144? 6 times 6 is 36. 4 times 22 is 88. Does that equal 144? We have, doesn't look like it. All right, so now I can see that I should have used a calculator myself. When I multiplied both sides by -4, I should have gotten negative 112, which should have given me then positive 32, which would have given me x equaling 16 then. So now if I check my answer, so if x is 16 and I needed a total of 28, then y would have to be 12, giving me a total of 28. And let's see if that works. 6 times 16, 4 times 12. 6 times 16 is 96 plus 48. Does that equal 144? 90 and 40 is 130. 6 and 8 is 14, so that does work this time. So it is very important to check your work. If you check your work, you can find out where you made mistakes, and that's how we'll end up here. So we had 16 $6 candles and 12 $4 candles. And that'll do it for this